graph of the square root of x, and they didn't have to give this to you because this was on one of your colored papers. You would be expected to know what that graph looks like. And we want a graph, and I'm going to rewrite it by putting the 2 on the other side. And you'd have to first remember to factor it. Because we have a horizontal compression and a horizontal translation, but it wasn't in factored form. And then I'm going to add the 2 to the other side. So we can do our labeling. This negative is a vertical reflection. That multiplies your y value by -1. Inside our function, we've got a horizontal compression, x by a third, a horizontal translation, 1 to the left, and finally a vertical translation, 2 up. Key points on our original graph. Well, definitely I would choose 0, 0. And based on what's happening, okay, you could pick 1, 1, but you see that you're going to get fractions. So I'm going to do it just to practice fractions. Here's 1, 1. But if I was picking a value on the square root graph that would avoid fractions, what should be my other point? 4, 2. I'd still get fractions when I multiply by 1/3 though. I want to try to avoid all fractions. What would 9, 3. Does that make sense that if I picked 9, 3, when I multiply the x by 1/3, I'll still have a nice number? So I'm going to show you what the fractions do. It's not bad. Fractions aren't bad. They're just a little bit more cumbersome to work with. So let's take those 3 points. We have on our original 0, 0, 1, 1, and 9, 3. Stretches and compressions first, then our translations second. We know for stretches and compressions our x gets multiplied by a third and our y gets multiplied by -1. So we're going to go 1 to the left and 2 up. So multiplying 0 is going to be easy. It's still 0, 0. 1/3 would give me a 1/3 here, but just a +3 there. Multiplying y by a negative, this will be -1 and -3. 1 to the left, -1. 1/3 -1. Now, how do you subtract fractions? You need a common denominator. 1/3 -3/3. This will be -2/3. And 3 minus 1 is just 2. 2 up, this will be at 2. This will be at +1. And this will be at -1. So again, I would recommend, let's draw this on a separate graph. We're going to have -1, 2. -2/3, 1, and 2, -1. 0, 0, that's your starting point of your x cubed graph. So that changes to this starting point here. That helps me to say this is where I'm going to start my graph. And it has to curve down like this. Can you see the vertical reflection? Okay, so sometimes it's nice that we wrote out those words in blue and green, or those abbreviations, because you can check afterwards, do I see a vertical reflection? in my final graph is the shape going now down and having that same curvature. Because the final exam, they're really concerned that your shape is good, like the right kind of shape. If you drew a nice straight line through each of these points, they take off a half mark. Because it's supposed to be curved like the original one is curved. Does it ask domain and range?
Yes.
Oh, but just of one. Okay, just the blue one wants domain and range. So smallest value is for x -1. So I can write -1 to infinity. Range has no smallest value, so we'd start at -infinity, but it has the biggest value of 2. And questions for practice, circle 8 and 10.